All right, this is Advent of Code day 7. What do we got? Got a camel. We have cards. I see. Bid multiplied by its rank. Oh dear. Okay, fine. Okay. Okay, so yeah, just doing this. Leave a kind. To pair. This is wrong. Uh, 113. 6. This is 1112. Add an assert. That might actually work. Oops. Six, 8, 3, 3? No. Jack, Queen, King, Ace. 6444. Some big random number. Nice. J is Joker. Yeah. Okay. So this is now this, I think. You just want to increase the biggest number, right? Think so. What do I want? It should be easy. I see. Five 905. Maybe? No. Huh. Okay. How do I debug this? This gets 5905. That is correct. Tiebreaker. Yeah. Okay. Great on part 1. Not so great on part 2. But it went, overall, good day. Okay, so what's going on here? This is kind of tricky. Yeah, I got an interview question once, kind of similar to part 1. At any rate, so we're given these hands of cards, and basically we need to sort them in order of strength. And that's essentially the whole problem. Then we checksum them, right? So you sort them and then you multiply the index times this number. And that's the same for part 2 as well, but the sorting is more complicated. So how do you sort them? So basically, you need to define the strength of each hand, which is given by its type, and then the list of cards. So the types are basically based on the counts, right? All 5 is best, then 4 of a kind, 3 and 3, 2, right? You can see I've enumerated all the types here, which is basically you want as big a number as possible. You want more big groups. 5 is best, 4 is second best, 3, 2, 3, 1, 1, 1, 2, 2. This is the same as in poker, actually. And then the sort of second tiebreak for things of the same type is by the hand. And it actually matters what order the cards are in the hand. You compare the first cards first. If one of them's lower, then that one loses. On to the 5th card. So this is a little bit... So what have I done? I've defined a strength function that takes a hand and gives, sort of follows that logic for you. This was such a terrible... Anyway. That follows this logic. So it uses counter, which is a built-in Python thing, which just gives you a dictionary. It takes in a list and it gives you a dictionary of item to how common that item is. And so I'm using that to sort of classify the type, and then I'll just return a tuple with the type and then the hand, and rely on Python tuple comparison to sort of do the comparison correctly. So tuple comparison works by first comparing the first thing, and then if they're equal, it'll compare the second thing. So by returning a tuple whose first thing is the sort of types sorted by strength, right? So this 5 of a kind has the highest number. the whatever high card has the lowest number. And then the second thing is the hand. So this is a little bit tricky. I need to make sure that the hand sort of sorts correctly. So the numbers will sort fine, but the letters do not. So what I've done is I've just replaced 10 with the character after 9, Jack, well, in part 1, Jack with the character after 10, you know, plus 3, plus 4, plus 5, right? And now 10 Jack, Queen, King, Ace will sort correctly. You could have also just replaced these, like every card with just its corresponding number, which is similar to what I'm doing here. This converts it back into a character. This converts a character into a number. This converts a number back into a character. Right, into like ASCII numbers. So you return the type and then the hand, and then, you know, if you sort according to that function, then you will get them in order, and then you can just go through them in order and, you know, add in the index times the, I think they called it the bid. So that is that. So that went super well. And then in part 2, jokers, so J cards are now jokers instead of jacks, and they're wild. So they can contribute to whatever is the best thing, you know, pretend to be whatever the best thing is to contribute to the hand. And here I did badly for some reason, and did not do a good job. So like the logic is relatively straightforward. You want, because these sort of types are sorted logically, you always want like the biggest group. So you should just add the jokers to whatever the biggest group already was. Which should not. So let's see. So what is a better way of doing this? So we're going to figure out what thing to add it to. If C of K is bigger than C of target, target equals K. So like, what is the thing with the biggest group that's not? So I've replaced J with 0 here for part 2, because the other thing it says is that J is the weakest card. Actually, it should be replaced with 1, because I didn't realize there weren't any 1s. And now I can write C of target equals, well, I suppose if 0 C tell C of 0, right? So for the purposes of counting, we're just gonna count 0, which is what I've replaced Jack with. Now it's 1. Sure. As the target. And then make sure that it's not in the list. And I had a dumb bug here where if the jokers were already the biggest group, I didn't correctly replace them. So that was my bug. And I believe this should still work. But it does not somehow. Oh no. Amazing. Trying to fix it up and I still can't get it right. Well. There's an annoying case where the hand is all jokers, in which case they can't help with anything. Sure. So this gives now 248, something 492, which looks correct. Is this really any cleaner? Not as much as I thought it would be. Sorry, that was a distraction. So the point is, I need to like rejigger these values so that the jokers are added to the biggest group, if any. It feels like there's probably a simpler way to do that, but I'm not quite sure what it is. So anyway, and then it's just the same as before, right? Now that we have the counts correct, just classify it again by the count, and this is the thing that implements the jokers being the weakest card instead of being between 10 and queen, and then just redo the sorting and get the same answer. Let me change this to actually print out both part 1 and part 2. Which I think will probably be easiest to just do it like this. And then this happens with part 2. And I was printing out a bunch of stuff, so let me clean that up. So this should be something 719-247. Cool. Okay. So now that I've done that, we can sort of clearly see what the differences are. The only difference is in the strength function. And in the strength function, there are two differences, which is sort of where Jack, or J, is in the position of the list. In part 1, it's between 10 and queen, and in part 2, it's below 2. And then also whether you do this thing with replacing the J, adding the J's to the biggest group when you're sort of classifying the type, or getting this list of like group sizes. That is it for day 7. See you tomorrow.